Okay, so let us continue. So, as I told you, നമുക്ക് ഇതെല്ലാം കണ്ടുപിടിക്കാനുള്ള മെത്തേഡ്സ് അല്ലെങ്കിൽ it is briefly given in that Khoslas curve how to find out all these questions. So first, let us discuss that and let's then move on to the problem. So, it's just a Khoslas curve, and this big one, the bottom portion, the curve for intermediate y. Okay, and here the first thing is given is a figure. Okay, this is a figure for intermediate file condition. So first you have to understand that. Okay, this is the weir structure and this is the intermediate file. At B1 is the distance between upstream and intermediate file. Okay, that is center to center distance. Okay. Now after that, D, small d is the depth of the intermediate file. Then the pressure points are E, C, and B. And B is the total length of the structure. Capital H is a head. Okay. ഇത്രയും കാര്യങ്ങളാണ് ആ ഫിഗറിൽ നിങ്ങൾ മനസ്സിലാക്കേണ്ടത്. Then ആദ്യം പറഞ്ഞിരിക്കുന്നത് നോക്കാം. To find phi E for any value of alpha and base ratio B1 by B. So you have to find out alpha and B1 by B first in case of intermediate file, and then to find out phi E, read phi C for base ratio 1 minus B1 by B and subtract it from 100. That is phi E equal to 100 minus phi C. Phi 2 equal to 100 minus phi C2 for our case. Okay. An example for phi E for B1 by B equals 0.4 and alpha equal to 4. Take 534 B1 by B equal to 0.6, that's equal to 1 minus 0.4 and alpha equal to 4. And you will be getting the values 100 minus 29.1, that's equal to 70.9. Okay. This is example number case that's example. Okay. After that, you have to find out the value for phi D. Okay. This method is how to find out the value for phi D. Okay, that is to get phi D for values of B1 by B. Okay, listen here. Either substitution on this. To get phi D for values of B1 by B less than 0.5. Okay. To find value of phi D for values of B1 by B less than 0.5. Okay, when B1 by B is less than 0.5, read phi D for base ratio 1 minus B1 by B. That is, when B1 by B is less than 0.5, take 1 minus B1 by B value. Okay, and read phi D and subtract it from 100. Okay, that's the things to find out phi D. Okay. And for example, that is when B1 by B equal to 0.4 and alpha equal to 4, take 100 minus phi D for B1 by B equal to 0.6 and alpha equal to 4. That's chart. Okay, the problem here is that, see, these are the curves of alpha, curves of phi D. And as you can see, the curves of phi D ends at B1 by equal to 0.5. Okay. ഇത്ര റീജിയൻ ആണ് നമുക്ക് 5Dയുടെ കേർവ്സ് ഉള്ളത്. This much region is the curves of 5D. നമുക്ക് ഇവിടെ കൊടുത്തിട്ടുണ്ട് curves of 5D എന്ന് ഇവിടെ എഴുതിയിട്ടുണ്ട്. അത് ഞാൻ ഈ ഷെയ്ഡ് ചെയ്യുന്ന റീജിയനിലുള്ള curves മാത്രമേ നമുക്ക് 5Dക്ക് വേണ്ടി യൂസ് ചെയ്യാൻ പറ്റുള്ളൂ. That is, you can see a gap here. Okay. ഈ this line ഇതിന്റെ താഴോട്ടുള്ള പോർഷൻ 5C ആണ്. Okay. Now, the problem is that the curves of 5D occur only at B1 by B only above the value of P1 by B equal to 0.5. That is look here it is P1 by equal to 0.5. അപ്പോൾ അത് ഇവിടെ വരെ ഉള്ളൂ. ഇതിന്റെ മുകളിലേക്കാണ് curves of 5D ഉള്ളത്. Okay. So when B1 by B is less than 0.5, there is no curve for such condition. So what we do is take 1 minus B1 by B. Okay. When it is less than 0.5, 1 minus B1 by B will be greater than 0.5. Okay. So in an example given in the sheet, B1 by B is given as 0.4. So 1 minus B1 by B 0.6. Okay. And for alpha value equal to 4. ഈ കേസാണ് നമുക്ക് ഈ ഒരു ഷീറ്റിൽ എക്സ്പ്ലെയിൻ ചെയ്ത് പറഞ്ഞിരിക്കുന്നത്. So 1 minus B1 by B equal to 0.6. So this is 0.6. So as we did earlier, draw a line here. That is 0.6. That is a line at 0.6 and alpha equal to 4. Okay, alpha equal to 4 നിങ്ങൾ നോക്കുക. That will be here. This is alpha equal to 4. After clear ആയിട്ടില്ല. This is alpha equal to 4. So intersecting point of this line will be here. So അവിടെ നമ്മൾ horizontal line വരും. Will be somewhere here. We will be obtaining it as value will be 40, this is 50, so it will be around 45. So you have to take 100 minus 45, that's equal to 55%. Okay. So that's the example given on the sheet. Now let us move on to our problem. Here is 55. ഇപ്പോൾ കണ്ടുപിടിച്ചു. ഇനി നമുക്ക് നമ്മുടെ ക്വസ്റ്റ്യനിലേക്ക് പോകാം. നമ്മുടെ ക്വസ്റ്റ്യനിൽ എന്തൊക്കെയായിരുന്നു ഉണ്ടായിരുന്നു? Alpha value was 9.5 and B1 by B was 0.3. See here, alpha value is 9.5 and B1 by B equal to 0.298. So we have to take the value of B1 by B for our case is less than 0.5. So let us take 1 minus B1 by B. That is, alpha value for us is 9.5 and B1 by B equal to 0.3, which is less than 0.5. Hence, we have to take 1 minus B1 by B. That is 1 minus B1 by B, that's equal to 0.7. So, so draw a vertical line corresponding to B1 by B equal to 0.7. That is here. Okay, that vertical line line for B1 by B equal to 0.7 and find out the line of alpha equal to 9.5. Okay. That is here. You can see this is alpha equal to 8 and this is alpha equal to 10. So that line will be almost same at this point. So you can take the value of 5D from here. This 5D. Okay. And the 5D value for our condition is this is 30, this is 40, this is 30. 31, 32, 32. Okay, that is 37, around 37. Okay. So that is how you find out. Now this is the reading that you got. To find out 5D, when B1 by B is less than 0.5, you have to subtract it from 100. 100 minus 37, that will be 63. Okay. So that is how you find out 5D. Okay, so hope that is clear. To find out 5D, you need the value of alpha equal 1 and B1 by B. Alpha and B1 by B1. And when B1 by B is less than 0.5, just take 1 minus B1 by B and take the reading and subtract it from 100. Okay. That's okay, just a minute. Okay. So here, we will consider 5D2. Okay, 5D2. Alpha value that is 9.4. Alpha's value is 9.5 and B1 by B equal to 0.7. Sorry, 0.3. So you have to take 1 minus B1 by B as B1 by B is less than 0.5. That's equal to 0.7. So now read the value of 5D for alpha equal to 9.5 and B1 by B equal to 0.7 and you will be getting the value of 37. So for this case, when B1 by B, as our case B1 by B is less than 0.3, you have to take the value by subtracting from 100 minus 37. Okay, and then 5D equal to 63. Okay, next that is we have to find out the value for 5C2. 5C2 is taken directly for the value of alpha and B1 by B. Okay. So three cases under. First 5E2, for 5E2 you take alpha and 1 minus B1 by B and subtract from 100. Then for 5C2 you take simply the reading for alpha and B1 by B, and for 5D2 again there will be a subdivision of two cases, that is when alpha, then B1 by B is greater than 0.5, simply read for alpha and B1 by B, and if B1 by B is less than 0.5, find alpha and 1 minus B1 by B, then subtract it from 100. That's the problem. You can examples on the other than the lens, so in the end, because it's late. So in the class, in the class, sure I to check. Okay, now let us move on to the correction. How to apply corrections for all this. Okay, then three pressures are controlled, that is 5E1, sorry, 5E2, 5C2 and 5D2. And that there is no correction application for 5D2. Okay, you need to apply the pressures for 5E1 and 5E2 and 5C2. These pressures are applied. So first, let us see correction for 5E2. And for that, we have first mutual interference at E2 due to pile 1. So that's the first correction that we are going to apply is mutual interference for at E2 due to pile 1. That is, let us see. I'm going to look into figure on again. So structure is a pile, and this is a second pile. Okay. So this is one, first pile, second pile. Okay. So first we have capital D. Okay, capital D and the height of the interfering pile. Okay, here, first we are finding the mutual interference E2. E2 is here. Okay, E2 is here due to pile 1. That is interference due to pile 1. Interference at this point due to pile 1. So this is pile 1. So capital D is the depth of that pile, and it is taken from the bottom of the structure. That is, structure in the top level was 154, and this is 153, and this is 148, and this is also 148. So capital D equal to 5. That is 153 minus 148. That's equal to 5. And small d is also equal to 153 minus 148. That's the depth of the pile that we are considering. Okay. So depth, capital D is the depth here, and small d is the depth here. Okay. That's equal to 5. Then we have B dash. B dash here is the gap distance between the two piles. So that is not the center to center distance. That is equal to 15.8. Okay. Then we have another value is B. That is the total width of the structure. That is 57. Okay, so substituting these values in this equation, you get 19 into the root of 5 by 15.8 into 5 plus 5 by 57. That's equal to 1.88. And the sign convention, according to sign convention, as I said earlier, when the interfering pile is in the backward direction of the point. The sign convention that we have studied is when the interfering pile is in the backward direction of the point, it is taken as negative. And when the interfering pile, in the first case, it was we found out the correction for 5C1 due to this pile. In that case, the interfering pile was in the forward direction. That is, it is positive. Here it is negative. Okay. So the interfering pile is in the backward direction, negative. Okay. So this is the interfering pile here. So that is in the backward direction of pile 2. So the direction is according to the flow. Okay. Flow is in this direction. So pile 1 is in the backward direction of pile 2. In that case, the sign convention is it is taken as correction is taken as negative. Okay. Now let's move on to next correction. Correction at E2 due to floor thickness. Okay. Floor thickness in the correction number can you apply the wall then. For that, we have simply 5E minus 5D by D2 into D2. 5D is 70. Sorry, 5E is 70, 5D is 63. So either you can simply directly take like this, or you can use a figure also like this. Okay. This is 5D. So this is the point of D2 and this is the point of D2. So here we can see 5E is greater than 5D. So for that, this 5E. So 5 and this is 5D. So draw a straight line between them to join them, and this is the thickness. And I join it draw a line here also. Now let us see. This is 70. This is 63. So you have to find out this value x, and this is 154, this is 153, and this is 148. Okay. So for the level, so you need to find out value here, that is phi e dash. So phi e dash is either directly given by this, that is ഈ ഫിഗറിൽ തന്നെയാണ് ഇത് വരുന്നത്. So either you can do it using this equation, or you can, from this figure you can calculate it by this base. You considering this small triangle and this big triangle. And for that, x by the base of small triangle by the base of big triangle, that is this much, that is 70 minus 63 equal to the height of small triangle, that is 153 by 148, sorry, 153 minus 148 divided by the height of the big triangle, that is 154 minus 148. Okay, so look, this is the x. Okay, this is not 5 here, that's the correction. Okay. So x equal to, you will be getting it as 1.17. Okay, that is negative. So this line, this is phi e, and phi e is phi e dash is smaller than phi e. Therefore, the correction is negative. Okay, that is, you have to subtract the value of correction from the value that we found out for phi e. Okay, so that is how you find out the correction for phi e2 due to floor thickness. Okay. Simply take phi e minus phi d. നിങ്ങൾ പഠിച്ചു വെച്ചാൽ മതി, ഫിഗർ ഒന്നും വരയ്ക്കാൻ പോകണ്ട, അത് എക്സ്ട്രാ സമയം എടുക്കും. So to decrease the time consumption, you can simply take phi e minus phi d divided by depth of phi multiplied by thickness of phi. Okay. So that is correction for floor thickness. Now next is correction due to slope. As there is no slope starting or ending at the pile due pile, the correction for slope is nil. Okay, correction for slope is considered only when there is a slope in the structure at the start point. So if the structure was like this and our pile is here, we will consider as a pile, it's not at the starting point of this slope. If the pile was here, then we would have found out the value for correction for slope here, so it is not required. So next we are moving on to correction for phi c. What we found out now was correction for phi e. Next we need to find out correction for phi c. Okay, for that the interference is from pile 3. Okay, let's see the figure. Yes, ahora por eso. Let's reply some more. ഈ അവർ തീരുന്നപ്പോഴാണ് 9:20. 9:10.
Sir, 10 വരെയുണ്ട്.
Okay. Absolutely. Okay. Okay, so let us see the figure. The figure goes like this. Now, this is our file 1, this is our file 2, and this is our file 3. Okay. Now this is file 1, file 1, file 2, and file 3. Now we are here the file. Sorry. File 2 comes here, not at the top starting, comes here. This is file 2. So now we have found out the pressure at this point. Now what we are finding out is a mutual correction at 5C. So this is here is a point 5C2 and mutual interference from file 3. Okay, at 5C2 the interference is from file 3. Okay, this is file 3. File 3 we are finding out the interference from 5C2. So for that, first capital D. Here you have to keep in mind that capital D is the depth of the interfering file, and that is measured from the top of that file to the bottom of the other file. Okay, that means it will be equal to capital D equal to 153. So 153 is the level here. This is 153. And bottom of that file is 141.7. Okay. Here it is 141.7. So, and after the capital D calculation is not the direct depth of the interfering file. Actually, you have to consider the bottom of the interfering file to the top of the considered file. That is the level difference between the top of the file that you are considering. That is this point to this point. So the level difference will be this much. Okay. This is our D2 value. Sorry, capital D value. Okay. That is 153. This is 153 and this is 141.7. So capital D equal to 153 minus 141.7. So that is equal to 11.3. So if this is a condition, capital D is measured from the top of file 2 to bottom of file 3. Okay, so that's how you take capital D, top of file 2, that is here, to bottom of file 3, equal to 153 minus 141.7. Yep, that's equal to 11.3. Okay. Or you can write it like this, that is the considered point is at the level, that is level 153, that is 5C2 is at 153 at point C2. Okay, that point C2 is at 153. Sure. Okay, system hang wait here. Okay, we will figure it comes like this. Okay, this is file 3, this is file 2, and this is file 1. 3, 2, and 1. Okay. So this is our point. The point that we are considering. This is a point. Okay. 5C2. This is C2. and this is the bottom of the pile, that is 141.7, and C2 is at 153. So that's the level difference, capital D equal to level difference between the point that we are considering, level difference between point under consideration, point under consideration, that is C2 here, that is C2 here, and the bottom of interfering pipe. Okay. Capital D, that is a point under level difference between point under consideration. That is here it is C2, bracket is C2, and the bottom of the interfering pipe. So that is point under consideration C2 is at level 153, and bottom of the pipe here, that is equal to 141.7. So the level difference is 11.3. Okay, so that's how you find out capital D for this case. Now, okay, similar, and the gap distance between pipes. Gap distance is 40. That is also given in the question. This is 40. Okay. So after substitution, we look here. This capital D is 11.3, B dash is 40, then small d, capital D, and small b, that is the entire line. So that is 2.89%. That is positive. So here, positive because the considered pile 3 is in the forward direction of the point that we are considering. So that is positive. Okay. The next is correction for thickness. In correction for thickness, any figure on the direct line എടുത്താണ്. That is correction for thickness. That's equal to, this is 5D and this is 5C. That is 5D minus 5C by small d into T. That is 63 minus 56 divided by 154 minus 148 into thickness, that is 154 minus 153. So that is equal to 1.17. That is positive. Positive എടുക്കുന്ന നോക്കുക. This is 0. This is 5D, this is 5C, and this is 5C dash. So this 5C dash is greater than 5C. Okay. So the correction obtained 1.17 should be added with 5C. Therefore, it is taken positive. Okay. Now, next, correction due to slope. Okay, so correction due to slope because C2, point C2 is at the start of the slope. Okay. Okay. Here it is at the start of the slope. So the point C2 is at the start of the slope. Okay. That's a one. So in this case, we have to apply the correction for C2 only. Okay, even if the pile is at the start of the slope, point E2 is here. Okay, point C2 is the point at which we apply the correction for the slope. Okay, for that, C2 slope, C2 is at the start of slope 3:1. Our slope question 3:1 എന്നാണ് പറഞ്ഞിരിക്കുന്നത്. So from table, okay, you have a table for the values of slope that I will give to you. So that for the table for the correction 3:1, the correction factor is 4.5. Okay. So correction factor is 4.5. So BS, that is equal to length of that slope. Okay, slope in the length is 3 meters. In the figure, it will be looking like this. Okay, this is 1:3. 3 എന്നാണ് ക്വസ്റ്റ്യനിൽ സ്ലോപ്പ് തന്നിരിക്കുന്നത്. 1:3 ആണെങ്കിൽ we have for that 1:3 the correction factor CF equal to 4.5. Okay, 4.5 that is, so correction to be applied is correction factor into length of the slope, that is 3/40, that's the difference between 2 pi. So here length of the slope എന്ന് വെച്ചാൽ ഉദ്ദേശിക്കുന്നത് in the question this is given as 3 meters. This is given as 3 meters. That is the length of the slope. That is 3 divided by 40. Okay, that's equal to 0.34%. And when the slope is upward, it is taken as negative. Okay, that is here you can see in the direction of flow. The direction of flow is in like this, and the slope is upward like this. So in that case, you can take the correction as equal to positive, and negative എന്ന് പറയുമ്പോൾ നെഗറ്റീവ് വരുന്ന കേസ് എന്ന് പറയുന്നത് ഇങ്ങനെ ഇരിക്കുന്നത്. Actually, when the slope is downward, flow direction is like this, and the slope is downward, and that case correction is negative. So here the correction is positive. Sorry, here the correction is negative, and sorry, for upslope it is negative, and for downslope it is positive. So here C2 is the start of the slope 3:1. That is 1:3 എന്നാണ്, അല്ലെങ്കിൽ 3:1 എന്ന് എടുക്കുക. ഇങ്ങനെയുള്ളൂ. അത് നിങ്ങൾക്ക് ആ ഒരു correction factor എന്ന ടേബിളിനകത്ത് is given as 1:1, 2:1, 3:1, etc. So if slope is 3:1 also, you can take the value for 1:3. Okay, തന്നിരിക്കുന്ന ടേബിൾ കിട്ടി 3:1. So 3:1 ആണ്, 1:3 ആണ്, ഒറ്റ വാല്യൂ തന്നെയാണ്. So for C2 is the start of the slope, that is here first നിങ്ങൾ മനസ്സിലാക്കേണ്ട കാര്യം, the slope is in the upward direction. So for that correction value is 4.5. The upward direction is depends on the flow. Okay, this is the flow direction, and the direction of flow it is in the upward direction. So first find out BS. BS is the width of the flow, that is equal to 3 meters. Then B1 is the gap distance between the 2 pi. So 2 pi ഈ സ്ലോപ്പ് ഇൻക്ലൂഡ് ചെയ്യുന്ന 2 പൈൽ, രണ്ട് പൈലിന്റെ ഇടയ്ക്കായിരിക്കുമല്ലോ ഫ്ലോപ്പ്. ഈ ഫിഗർ നോക്കിയാൽ this is 1 pi and this is other pi. So this slope is in between these 2 pi. So B1 is the gap distance between those piles, that equal to 40. So that's equal to 40. Therefore C equal to 4.5 into 3/40, equal to 0.34. And when the slope is in the upward direction of the flow direction, then it is negative, and when it is in the downward direction, it is positive. So corrected 5C2 equal to 56 is our value, plus 2.89. Okay, corrected value for C2 is 56 plus 2.89, that is correction for interference is 2.89, that is positive, plus 1.17, that is the correction for thickness. Correction for thickness, that is positive, and then we have correction for slope, that is 0.34, that is negative. So corrected 5C2 is 56 plus 2.89, that is the correction for missed interference, plus 1.17, that is the correction for thickness, and correction for slope is minus 0.34. So the corrected value of 5C2 is 59.72. Okay, ഇതുപോലെ തന്നെ നിങ്ങൾ ആ E2ന്റെ കേസിലും നമ്മൾ കണ്ടുപിടിച്ച വാല്യൂസ് വെച്ച് കറക്ഷൻ അപ്ലൈ ചെയ്യണം. Again, question. Okay,
Okay,
that's
that's enough for today.
you can leave now. Be ready with the homework tomorrow. Not tomorrow, on Monday. Okay, thank
Thank
you.
you.
Thank you, sir.
Thank you, sir.
Thank you, sir.